We're going to review 10.7 today. I want you to try this on your own. Let's see if you remember. Go ahead, everybody. I'll give you some time. What do you do with this? Go ahead. I want you to grab the solutions on this, okay? Go ahead. See if you remember how to do this. Okay, so what should we do first? Yeah. Yeah, make it so that it looks like a slope-intercept form. Is it really a slope-intercept form? No, because slope-intercept form, you need an equal sign, right? But this one is an inequality. But you know what I mean. Okay, so what do we do first? Just subtract 3x from both sides. And of course, you get x less than or equal to negative 3x. What's this? X less than or equal to negative 3x plus 3. Now from here, do we know how to graph this inequality? What do we start? By the way, what is your boundary line? You guys remember what the boundary line was? What's the boundary line? Alex?
It's the line on the left side of the inequality. Or I'm not the right side. And it's basically you can't go beyond that when you're shading.
Yeah, it's the line that bounds where you shade. What is the equation of this boundary line? Yeah. Yeah, you just make it into an equation. You just replace the inequality with an equal sign, right? Isn't this your boundary line? Y equals to negative 3x plus 3. You guys remember this? Do you know how to graph that line?
Yes.
You better be able to. Okay, so where do we start? Your y-intercept at 3. Your slope is negative 3. So you start at the y-intercept at 3, go down 3 to the right 1. Remember? Is this going to be solid or dotted?
Solid.
Solid, because it says y is less than or equal to. And so it's going to be solid. Now, here comes the part where a lot of you messed up on. Do we shade above or below?
Below.
How many people say below? Raise your hand. How many people say above? How many people are not so sure? Okay. Yes, it says y is less than. That's a hint. Y is less than. When it was equal to, it was this line, wasn't it? What does the y value tell you? It is the height of each points, right? So if it's below, if it's less than, isn't it below like this? Oops. Right? Isn't it below?
Yeah.
Now, what if I'm not so sure? What can I do to check and see if I have the right shaded region? Is there a way to check and see if I have the right shaded region? Yes, Liam. Yeah, you could plug in the points, right? Any coordinates. Because what does this represent? What does the shading part represent, guys? Yeah.
All the solutions to that inequality.
Excellent. This represents all the solutions, all the shaded part. It represents all the solution to this inequality, right? Now, what do these solutions look like? There are a bunch of points, order pairs, that happens to be on the left side of this line, right? So it's either left side, or it's either below this line or above this line. So why not pick a point, right? And if I pick a point that happens to be the solution, when I plug it in, guess what? It should come out to be. If I plug in a solution to this inequality, what should it come out to be? Yeah.
Should come out to be anywhere in that shaded area.
Yeah, so if you were to plug in a point from the shaded region, if we did this correctly, when I plug into this inequality, the inequality should be what? The statement should be what? True or false?
True.
True. That's what its solution is, right? Hello? You know what I'm talking about? Which point should I choose, though? I have so many points to choose from. How many points are there, by the way, on this left side of this line? I mean, bottom of this line. Yeah.
Infinity.
Infinitely many. There are infinitely many solutions. So which one should we choose?
All of them.
No, you can't choose them all. There's so many. Yeah. 0, 0. Why choose 0, 0? That's the easiest one to plug in, isn't that right? You could plug in 1, a negative 5 or something, but why do that, right? Why not just choose 0, 0, which happens to be part of your solution? When I plug it in, guess what? I get 0 less than or equal to what? 3. Is 0 less than or equal to 3, guys? Isn't that true? So we know for sure we did this correctly. Does that make sense? Do you guys remember this? Hello? Yes? No? Isn't this how we check and see whether we got the right answer? Okay. May I go to example 2? Any question on example 1? No? We good? Yes? Okay, let's try example 2. What if I give you this? This one's a little bit different. It's missing one of the variable, but we still know how to graph this, don't we? Go ahead, everybody try. Who can tell me the boundary line? What's the equation of the boundary line for this inequality? Raise your hand. One person knows. 2. What's the equation of the boundary line here? Aram? Y equals 1. You just replace the inequality with... Can I write BL for boundary line? Is that okay? You just replace the inequality with equal sign. Now, what does this look like? Y equals 1. Do you guys remember? Yeah, Arjun?
Straight.
All lines are straight, but what kind of straight line? It's a horizontal line is correct. Now, what if I forgot that this was a horizontal line? What can I do to convince myself that this was a horizontal line? You do it, make a little table. You make a little chart, right? What does this chart? How do I make this chart? Y is always what? Y is always 1. X could be any number you want, right? So here's a chart. You see how I'm going to get a horizontal line? Hello? Now, do I shade above this horizontal line or below? It says Y is less than 1. So how many people think it's above? Raise your hand. Okay, how many people think it's below? You are correct. How many people are still not sure? Okay, it says Y is less than. So when it's less than, right, it is below this line. Isn't that right? Does this make sense? Is there a way to check and see whether we got this right answer? Do we choose the right region? It's either above or below this line, right? So how do we check this? Plug in 0, 0. Isn't that the nice point to plug in? So when I plug in 0, 0, do I get a true statement? Yes, I do. Isn't 0 less than 1? By the way, there is no place for us to plug in x. Is that okay? Yeah, if there's no x, you don't plug in x, okay? You just plug in y. So do we always choose 0, 0? No, there are times where you don't want to choose 0, 0 to check. Can somebody tell me when you don't want to check, when you don't want to use 0, 0, when you check these? See if which regions is the correct region. When? Yes, Angela, when do you not want to check? That's right, when the boundary line goes through 0, 0, right? You don't want to check 0, 0 as your checking point. Why not? For example, like let's say I have a line that goes like this or something. Okay? How do I know, why do I not want to use 0, 0 as my point to check and see whether I should shade it above or below? Why would this be a not good choice? If this line goes through 0, 0 right here, okay, let me draw a little better. Okay? Why isn't 0, 0 a good point to choose? To check and see which way to shade. Raju? Yeah, it's not. It's on the boundary line. It's not on the shaded region, so it's not a good. So then, what do you do if you can't use 0, 0? You should use. Yeah. You could use 1, 1, if that's not a point that is on the boundary line, right? Basically, you don't want the point that you're checking to be on the boundary line. Or how about 0, negative 1? How about 0, 2? Is that okay? Do you understand? Okay. Oops. All right. Now, what if 0, 0 is not part of your solution? In other words, what if you get a graph? So let's graph y is now not less than 1, but how about if I graph y is greater than 1? How would that change? By the way, why is this dotted? Emily? Yeah, so what if I graph y is greater than 1? Now I should be grading above this, right? So if 0, 0 is not part of my solution, is that okay to still use 0, 0 to check? Yes, it is. It's okay. Why? Why is that okay to check 0, 0? Because 0, 0 is nice points to plug in. Isn't that the easiest point to use? But why is it okay to use 0, 0 as your point to check and see which region is your solution? Yeah. That's right. If it ends up being not your solution, right, then you know it's the other side. So then you know you did it correctly. Does that make sense? So when you plug in 0, 0 to this, you expect 0, 0 to be a what? False, right? Because then we know it's not on that side. It's got to be other side. Does that make sense? So just because 0, 0 is not part of your solution, you can still use 0, 0, right? You know that it's got to be false then when you plug in, right? Because it's either below this line or above the boundary line. Do you know what I'm talking about? Does that make sense? So even if 0, 0 is not your part of your solution, you could still use that. You could still use that to check and see if you got it right. Hello? Yes? Okay, now what if I give you this equation? Inequality. Now instead of y, now I have x greater than negative 2. How would you graph this? Okay, go ahead and try, guys. Give you some time. Who could show me, or who could tell me what is the equation of the boundary line for this? So that's my boundary line, right? Now, what kind of line do I get when the boundary line is equal to x equals negative 2? Yeah, Paula? I get a vertical line. You're correct. Now, how do I know? How can I check? I could do a little table again, right? My x is always going to be what? My x is always going to be negative 2. My y is going to be anything you want. So as you can see, my x is fixed, right? That means I'm going to get a vertical line. Now, well, I got a problem though. How do you then shade above or below a vertical line? Because there is no above or below. Brandon?
Well, since it's x and not y,
Uh-huh.
the shade goes left or right.
Yeah, you shade either left or right because you got a vertical line. Now, which way? How do I know where to shade though? It says x is greater than negative 2. Is it going to be right side of this vertical line or left side? Sorry? How many people say right side? How many people say left? How many people are not so sure? Okay, it says x is greater than negative 2 means every value that is greater than negative 2 is going to be on the right side, guys, right? So that's your graph. Isn't that right? Right? Every x that is greater than negative 2 is going to be on the right side of it. Isn't that right? Now, how do I convince myself that this is the correct region that I reshaded? We can plug in. Alex, what? How do I check this? Yeah, you can plug in 0, 0, but you don't have place for y, so you just plug in 0 for x, and we expect it to be what? True or false? True, because that's what, okay. Does it come out to be true? That's this out. Yeah, it comes out to be true, right? Is 0 greater than or equal to negative 2?
Yes.
Yes, okay. Any question? You plug in negative 2 there. So when you plug in negative 2, that's probably not a good point to plug in. Why not? Why do I not want to plug in negative 2 in here? Yeah. Yeah, it's on the boundary line. That doesn't tell you which way to shade, right? The point that you're checking must be not on the boundary line, because then you don't know. So that's, okay, so any question? Does this make sense? Hello? Are we good, guys? Yes? Okay, why don't you all try this yourself then? Here's an example 4. I want you to, it says 3y minus 1 greater than 2x minus 7. See if you know how to graph this inequality. Go ahead, everybody try. Okay, what should we do first here? Ellie? Yeah, add 1 to both sides because you want the y by itself, don't we? So we get this. Grace, what do I do next? Divide by 3. So I get, do I reverse the inequality symbol at all? No, none of them are negative, okay? So when you divide, it's positive, it's fine. So you get y greater than 2 over 3x minus 2. Okay? How many people shaded above this line? How about how many people shaded below? Okay? It should be above, right? And you could even check, plug in 0, 0. Again, 0, 0 happens to be a solution, right? And when you plug it in, you expect it to be true, right? So it does come out to be true. Any question? Is this easy? Hard? Okay. Okay, tonight's homework will be, remember we did systems before. We had to graph 2 of these, right? Now you just have to do 1. Okay, tomorrow you'll do 2 at a time. Okay, but today you just do 1. Any question? Are we good? Yes? Okay.